This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Please see video on independent events and the multiplication rule before continuing. Conditional probability occurs when events are not independent. There is a reliance of the second event on the first event. An example of dependent events is where there is a deck of 52 cards and a card is drawn. The card is not replaced. This is very important for dependent events. If the card had been replaced, the events would be independent. However, in this case, the card has not been replaced. If a second card is drawn, the probability of what the second card is has been affected by what was the first card drawn, as the deck has changed between draws. The conditional probability of B given A is written as this means the probability of B given that A has already occurred. This vertical line here is the mathematical notation for given. The conditional probability of B given A is equal to the probability that B intersects A divided by the probability of A. This rule can be written in a number of different formats. For example, if we multiply across by PA, we have the probability of A multiplied by the probability of B given A is equal to the probability of B intersection A. Now if we bring the conditional probability across the equals, we get the probability of A is equal to the probability of B intersection A divided by the probability of B given A. We'll now use this rule in some questions. The question states, in a mixed gender school, there are 5 boys and 4 girls on a basketball team. One student is selected from the team, followed by a second student being selected. Firstly, we have to find the probability a girl is selected, followed by a boy being selected. So if we think about this, probability first is girl. We have 4 girls on the team, and we divide by the total number of team members, in this case 9. Next, we want the probability that the second student selected is a boy. So we have 5 boys. Remember, we have already selected one student, the first student, which was a girl. So now we have only 8 students to choose from. Really, this second probability should be the probability that the second is a boy, given that the first was a girl. Which is our conditional probability. So using our conditional probability rule, the probability of girl and boy is equal to the probability of a girl, where A represents the first event, multiplied by the probability of a boy given a girl. And we have the probability of a girl is 4/9, and the probability of a boy given a girl is 5/8. Multiplying those together, we get 20/72. So the first answer is 20/72. The next question asks us, what is the probability the second student is a boy? So we could have that the first student is a girl and the second student is a boy. which we already know to be 20 over 72. Or we could have that the first student is a boy and the second student is a boy. So we need to find out the probability of a boy, then a boy. Using our conditional probability, this is equal to the probability of a boy as our first event, multiplied by the probability a boy is selected given a boy has already been selected. So looking at this, the probability boy is selected is 5/9. Now we already have selected one boy, so for the second section there's only 4 boys remaining and 8 students. So in this case it's 4/8. 5/9 multiplied by 4/8 gives us 20 over 72. So the probability the second student is a boy can happen in 2 ways. The probability of a girl, then a boy, or, which in probability rules is a plus, the probability of a boy, then a boy. So to find this, we add our 2 probabilities together, 20 over 72 plus 20 over 72, and we get 40 over 72. And simplifying, we get 5/9. In this question, the Venn diagram contains probability values. The question asks us to use the Venn diagram to calculate probabilities. The first one is the probability of A. The probability of A is all the probabilities falling within the circle of A. In this case, it's 0.3 and 0.4. So the probability of A is equal to 0.3 plus 0.4, which is 0.7. Next question is the probability of A complement. The probability of A complement is equal to 1 minus the probability of A. This is otherwise referred to as what is not in A. In this case, it's 1 minus 0.7, which is equal to 0.3. We could have found it by looking at the probabilities not in A. In this case, 0.1 and 0.2, and adding up these 2 values to get our 0.3. Moving on, the probability of B is all of the probabilities in B. In this case, the probability of B is equal to 0.4 plus 0.1, which is 0.5. Now I'll tidy up the slide. Next question is the probability of A and the probability of B, which we also know as the probability of A intersection B. Using the diagram, this is here, the intersection part. So the probability of A intersection B is equal to 0.4. The next question asks us for the probability of B given A. We are going to use the conditional probability formula. So the probability of B given A is equal to probability of B and A, which is the same as probability of A and B, in this case 0.4, divided by the probability of A, which we've worked out as 0.7. If you put this into the calculator, you'll get a value of 0.57 when rounded to 2 decimal places. An important thing to know is, in general, the probability of A given B is not equal to the probability of B given A. We have already calculated the probability of B given A. To show this, I'm going to calculate the probability of A given B. If we apply this to our conditional probability formula, we get this is equal to the probability A and B divided by the probability of B. Filling into this, we get the probability of A given B is equal to the probability of A and B, which is 0.4, divided by the probability of B, which we have as 0.5. 0.4 divided by 0.5 gives us 0.8. So the probability of A given B is not equal to the probability of B given A. That concludes the discussion on conditional probability.